Here is our final test. So the test for linear correlation. So I don't know if many of you are going to be using this, but I'm gonna put it here anyway. So if you have a numerical variable and you're comparing it with another numerical variable, then you want to be able to think about linear correlation. Okay, so think of linear regression, which we covered in the beginning of the semester. Okay, so couple things about this. You need continuous data. You want to make sure that you have absence of outliers, and you want to make sure that you have linearity. Okay, I will tell you that this one's easy to fix. These two depends on what your data looks like. Okay, typically we're only looking at linear regression. If it looks something different, then you have to do other different things, but we're only going to look at these three. Just linear regression and these three assumptions. Okay, so how do you do this? Now, typically, the way that you write your null and your alternative is many different ways, but the way that we're gonna write it is the following way. We're gonna say slope is 0, slope is not equal to 0. Okay, we're just gonna write it like that. In many other classes, you might actually see the word rho. So rho is equal to 0 or rho is not equal to 0. So you might actually be seeing this. We're not gonna do this in this class. We're just gonna write slope. Okay, so it really just depends. If you are a person who is not in my class, maybe what you're looking for is rho. Okay, but basically what the slope is, if you remember from linear regression, you have your data from a scatter plot, and you're going to have a line that best fits the scatter plot. And that line is in terms of y equals b0 plus b1x. So your slope is going to be this b1. Oh, wait a minute. We did something different. We did b plus ax. So a, in this case, is your slope. If your slope is 0, that means that it looks like this. This is telling you that there is no correlation. Okay? The other one's telling you that there is some sort of correlation. Don't know what kind of correlation there is, but there's a correlation there. Okay? So that's basically what that's telling you. So let's go to our data. And let's say we want to take a look at, I don't know, this is from last time. Let's say if my sleep is associated with my GPA. So the number of hours of sleep that I get associated with my GPA. Now, before we start, we need to make sure that both of these guys follow the assumptions. Now, already GPA is continuous, which is good, but sleep, you can see that sleep is discrete. Okay, you have discrete numbers. So when you think about your assumptions in terms of continuous data, is questionable because sleep is discrete. So I don't know. Okay, it's gonna look really funky. Linearity. Okay, so absences of outliers and linearity can kind of go together. One way that you can test both of these guys is by doing a scatter plot. So quick and easy scatter plot, which maybe you have already done in your descriptive analysis portion. So you're going to go to your scatter plot, so press graph, and then we're going to click on scatter plot. And here you're going to use your x variable and your y variable. I want to look at my hours of sleep, and I want to be able to predict my GPA. Okay, and then I'm going to click on compute. So yes, this is basically what I thought. So for one, we have an outlier here. Someone had 20 hours of sleep, so that's not good. So let's get rid of that guy. Okay, let me actually get rid of it. So let me clear it. Let me run it again. I don't know if it's really gonna do anything, but let's see. So I'm gonna look at sleep and predict my GPA. And then, yeah. So it basically looks all weird like this because you have discrete numbers. See, I mean, only a couple of people said 5.5. But everything is kind of, all over the place. I don't really see a lot of pattern here. I mean, maybe a little bit. Maybe you can see that the more hours of sleep these guys tend to have a higher GPA. It's kind of hard to tell. So this doesn't look very linear to me. I got rid of the outliers. So linear, I'm not sure. Okay. Not sure about linearity. So I got rid of the outliers. Linear, not really. Not really linear. And that's mainly because you had discrete data. So that becomes a problem. So that means that when we do this test, I don't know, we should not really do not trust the results. Even if we reject or don't reject, don't trust these results because already the assumptions are not being met. So let's go ahead and do the test. So there's many different ways that you can do the test. The first way to do it is, I think, the way that you all know how to do is click stat, then regression, click simple linear, click on your x variable, which is going to be your sleep, click on your y variable, which is going to be your GPA. Here you can see hypothesis testing. You see the intercept, which we don't care about, and we look at the slope, which is what we want. Okay, so slope equals 0, slope is not equal to 0. Let's click on compute. All right, so we look at this, and here we have basically the linear regression analysis. Okay, we have our R squared and our correlation coefficient. So we can also see the correlation coefficient is very, very small. Okay, so not a lot going on there. Okay, so if we look at our slope in this case, here is the p-value for the slope, and it's a high slope. I'm sorry, it's a high p-value. So what you might want to do is not reject. So you can kind of say that the slope, you're going to not reject it. So there really is no correlation between these two. You have other stuff. This is a ANOVA test, but this is for something different. So yeah, this is a way that you can get the p-value. Another way that you can get the p-value, I think this is probably the better one because it tells you everything, but including the correlation and R squared and all that other stuff. And you might want to take copy paste all that. Another way that you can do it, I think, is if you click on summary stats, correlation, and then I can click on the two variables, which is GPA and sleep. So let me control. So I have GPA and sleep. Two-sided p-value. Oh, okay, it does do it. Okay, two-sided p-value. You're not grouping it by anything. Unless you really want to. If you want to group it by males and females, it doesn't matter. Okay, so compute. And yes, okay, so you do get the same thing. So you do get your p-value. So you get your p-value here, and you also get your correlation. Okay, so two different ways you can do it. I think the other one gives you much more information. So just make sure that you do check these assumptions to just let us know whether this can be used or not. And then obviously you will use it, although it's bad. Do it and then and then say, oh, even though we rejected or we didn't reject, again, our assumptions were not satisfied, so we would have to use other methods.